Okay, here's a question that came across my desk from a student about exponential decay that I think's worth going over because I think it's a little bit confusing or misleading. So we're at the top, number 4. In 2021, the number of students enrolling at FSU North Campus was 75,159. Over the past 10 years, there's been a 4% decline. Write an equation to depict this change. Okay, so far so good. And then they give us a little extra equation. Sub in the value for A, the principal value, and the decay factor is 100% minus 4%, so which is 96%, right, instead of 9%. So 0.96. So you're retaining 96% of enrollment each year. If this percent of change continues, what is the college population? What is the expected college population in the next 5, and then it should be years, I imagine, if they want the 5th year or if they want all 5. So 2022, 2023, 2024, 2025, 2026. Okay, so the way we would do the next 5 years, I'm going to take this away. And I'm going to back out a little bit. Hope we get our focus back. Okay. Good. So here's our initial, 75,159, and here's our rate of decay. So if I want the next year, which is 2022, I put 1 in, and we'll put that into the calculator. 75,159.96 power 1. So I get 72152, and I would just truncate it, or just basically you're rounding everything down so that you don't have a fractional student. Right, so then I would just pull up my last equation, change in the number to 2, and that would go to 69,266, and then 3, 6, 6, 4, 9, 5, 4, 6, 3, 8, 3, 6, and then 5, 61282. 61282. So if we're looking for the 5th year, that should be the one we want. However, this is not. It says we want to write an equation for the situation where over the past 10 years there's been a 4% decline, and we end up with 75,159 students. All right, so what we're actually solving for is A. So what I want is to know how many students there were 10 years before that in 2011. So I take A, and I know that my rate is 0.96. I take that over 10 years, and then I want to end up at 75159. So that would be the equation that represents the situation. It doesn't give you 5 years out, but what it gives you is, if I divide both sides by 0.96 to the 10th, oh, did I lose it? I take 7, clear it out. So what I'll do is 75159 divided by 0.96 power 10 on these. I gotta hit right. And I get bad marker. 113,049, and then I'm gonna add the decimal so that when you do 4% for 10 years out, you get exactly 75159 back. And notice you can't start with this value and then you can't add 1.04. You can't add 4% retroactively because you're talking about 4% of a smaller number. So I hope that clears up a little bit of the confusion. I just had to read it through a few times, and then our best bet for what they actually wanted was the where are we going? 61282. That's right here. Okay. This also, I don't know if they're in the lesson yet or not, but we haven't solved yet on this lesson how many years it would take, right, at 4% decline to get to 60,000, right? So you could keep going. This after 5, you could go 6 years, 7 years, 8 years, you know. So if I have 75159 times 0.96 power 6, right, so then I'm already down to 58,831, right? So if you haven't been taught logarithms yet, you could still just extend it out, and then, you know, between, you see it'd be between the 5th and the 6th year. Or you could say 75159 times 0.96 to the t power equals 60,000, and then we would divide both sides by, I forgot, that's not great, 75159 60,000 divided by 75159. So I get 0.96 to the t is equal to 0.79831, and then I would take the log of both sides. And then I would get t, the t would come down here. So I would get t times the log of 0.96 equals log 0.79831. And then you divide both sides by log 0.96. So on the calculator, we'll use the base 10 log, 0.79831 divided by log 0.96, and you get about 5.52 years. So between the 5th and the 6th year after 2021, right? But my point is more that you could, without doing the logs, if you just go a couple more years right now, you could solve that problem. All right, so I hope this helped in some way, and if you have questions, you know, on this lesson or others, you know, go ahead and ask them in the comments, and I may be able to help. Thank you.